So we're going to carry on from what we did yesterday and do composition of functions. So with composition of functions, it's basically function notation on steroids. So we do F with this little circle in the middle. This is not times. The circle means of. So we're going to compose these two. So F of G of X, F of G of X. And so we can write this as F of G of X. And so we start inside out with the parentheses inside, or the inside function. In this case, it would be G. And we use the outside function to put the parentheses in. And we're going to use our function notation rules to make this work. So we're going to write parentheses everywhere X is. We're going to plug in the value or expression, and most of the time it's going to be an expression where the parentheses are, and then again we're going to simplify. Sometimes we'll be able to simplify, sometimes we won't. Okay, now I did this worksheet upside down, so your homework for today is actually the bottom part, and the homework for tomorrow is actually the top part. So I'm going to do them in order, but they're actually reversed. Okay, so just know that when you're doing your homework, this up here is tomorrow's homework, so this is the evaluating. So this is composition evaluating. Okay, so if you're looking for what to do, that's here. And a lot of times it's easier to start here, so that's why I like to start with the numbers. So I always rewrite this so I can see. This is equal to F of G of 1. So I'm going to start and I'm going to plug 1 into G first, okay? So I'm going to take everywhere X is in G. So G of X is G of 1 is what I'm looking for. So I say 4 times parentheses, because here's X, and I'm going to plug in this 1. So G of 1 is 4. So now this middle part right here becomes 4. So now, let's see if I can change colors here so you can see what's going on. So now this inside of here, this part right here, is 4. So now what we have is we have F of what we just found, which is 4. So now that's what we're looking for. We were doing F of G of 1. Well, G of 1 was 4. Okay, that was 4. So now we want F of 4. So now we're going to go and we're going to find F of 4. So we're going to take the F function, and everywhere X is F of 4, right? So everywhere X is becomes a parentheses. So 2 times something squared, I'm going to draw a line here so we don't get confused, minus 3, and we're filling in this number right here, 4. I'm plugging this straight in my calculator. 16 times 2 is 32, minus 3 is 29, and that's my answer. Okay? So same thing over here. I'm going to do F of negative 2. I wonder if I can get this any bigger. Let me see if I can blow this up a little bit and see if I can give myself a little bit more writing room. Let's see if that helps. So F of negative 2. So I'm going to plug negative 2 into F. All right. So remember my F function is this. So I'm going to go over here and I'm going to do F of negative 2. So 2 times something squared minus 3. And I'm filling in this negative 2. So now I'm going to work this out. I'm going to put this right in my calculator. So 4, 8 minus 3 is 5. So now this whole thing becomes 5. This is what we just found. This right here is this right here. And so now we have f of 5. Okay, so this becomes this. So now we're going to find f of 5. So we know that it's 2 times something squared minus 3. We're filling in 5. 25 times 2 is 50 equals 47. And that's our final answer. Okay? We're going to go down. We're going to go down and do this problems right here, maybe, if I get my computer moving. Come on, computer. Maybe. There we go. So we get g of f of 1. So we're going to plug a 1 into f first. So 1 into f of 1 is 2 times some 1 squared minus 3. So that makes negative 1. So this whole thing, I'm going to change colors here for you. So this whole thing is negative 1. So now we have g of negative 1. So it's 4 times negative 1 is negative 4. That's my final answer. Okay. So now we have g of negative 1. So I'm going to plug negative 1 into g. So 4 times negative 1, right? Because that's g of negative 1. That gives me negative 4. So I'm getting all kinds of colors here for you. So this part right here is negative 4. So now we want g of negative 4, right? That's this part. So now we want 4 times negative 4, which is negative 16. And that's my final answer. So that's what you do when you're evaluating. You take the inside number, plug it into the inside function. Then when you get an answer, you plug that into the outside function. All right. Now, when you're composing functions all together, so when you do composition of functions, let me get I don't think this orange is going to be too bad. Let's try purple. So when we do composition of functions, let's do. So this is composition of functions. This would be tonight's homework. Probably did this backwards. I know, I'm sorry. So this says take f of x and plug it into g. So that means this gets g of something, okay? So everywhere x is in g becomes a parentheses. So we get 2 times something plus 3. And that's hard to see. Let me get rid of this line here over our function here so we can see it here. Come on. Oh, of course, it erased the whole line. Okay, so anyways, let me get back to my pen. So what we're filling in is f of x. So we're filling in f of x. Well, f of x is this whole thing. Well, obviously I didn't leave enough room. So I'm going to fill in f of x. Well, what is f of x? Well, f of x is x squared plus 3x minus 1 plus 3. So now I'm going to simplify this. So I would get I would distribute 2x squared plus 6x minus 2. Don't lose this plus 3 out here. Combine like terms. So I would get 2x squared plus 6x plus 1. Final answer here. Okay, so I just distributed this. On this one, come on, slide. So on this one, I'm plugging g into f. That means everywhere in f becomes a parentheses. So this becomes x squared plus 3x minus 1. And I'm filling in g of x. Well, what is g of x? Well, g of x is 2x plus 3. So I'm filling in 2x plus 3. So on this part, remember I said if there's a square, we got to do a box. So let's go over here and do the box. So 2x plus 3, 2x plus 3. That box isn't big enough. Bad Miss Smith. 4x squared, 6x, 6x 9. So this gives me 4x squared plus 12x plus 9. So this is 4x squared plus 12x plus 9. This I'm going to distribute because there's no box here. So plus 6x plus 9 minus 1. And then I'm going to simplify that. I'm going to add like terms. So the only like terms I have here is 12x and 6x. So 4x squared, 12x plus 6x is 18x. And then my other like terms here are 9 and 9 and negative 1. And so 9 plus 9 is 18 minus 1 is 17. So that's my final answer there. Okay. So sometimes composition says, this is kind of like function notation as well as composition, tells me to put this function into this function. So again, anywhere G has a parentheses, G of X, but instead of X, I want 3X minus 1. So everywhere X is, put a parentheses, and I'm filling in 3X minus 1. So I'm going to distribute. I get 6x minus 2 plus 3 equals 6x plus 1. There's your final answer. On this one, f of 2x. So everywhere x is becomes a parentheses. And so I get x squared plus 3x minus 1. I'm filling in 2x everywhere, everywhere, everywhere. And so I get 2x squared is 2x times 2x, which is 4x squared. And 3 times 2x is 6x minus 1. And there's my final answer. Okay, and so that's all you'll do for composition of functions. And again, this should be review for you, mostly review from Math 3. And that should be all you have to do.